Hello everyone. In this video we are going to see ER diagram for university database. So various constructs of the ER model that we have studied so far, we would like to apply these constructs to a real world problem solving, and that is why we have selected this university database so as to apply the ER model constructs and come up with a full-fledged ER model for this university database. So before actually going for the university database and the ER diagram for the same, let us summarize the symbols. Those are to be used while drawing the ER diagram. So in fact we have gone through these symbols, but this is the summary. So we are having the entity set denoted as the rectangle, weak entity set. So strong entity set is denoted as the rectangle, weak entity set is denoted as double rectangle, then the relationship set is denoted as a diamond. Identifying relationship set for weak entity set is denoted as double diamond. Then about attributes, the oval is used, or the ellipse is used to denote the attribute, double ellipse for multi-valued attribute, dashed ellipse for derived attribute. Then if we would like to represent the primary key, then we are using the underline for that attribute denoting the primary key. Then if we want to depict partial key or the discriminating attribute of the weak entity set, we are using the attribute with dashed underline, and this is the discriminating attribute in the weak entity set. And total participation of entity set in relationship is denoted with this double link in between the relationship set and the ER entity set. Okay, now few more symbols or notations related to mapping cardinality. So just look at it: many to many relationship, many to one relationship. So arrow is being used towards one, then one to one relationship. Then even we can put the cardinality limits, right? Instead of showing the cardinality with the directed or undirected arrows or undirected lines, we may use the cardinality limits denoting the actual cardinality of the relationship, and this is how we may denote it, the lower limit and the higher limit. Then if we would like to mention the role, then the link between the entity set and the relationship set is being labeled with the role name. Then the specialization and generalization is being depicted using such kind of a triangular notation. Total generalization or total specialization is denoted with this double line with a triangle. And if we would like to depict the disjoint generalization or disjoint specialization, then the word disjoint needs to be written along with this triangular easy relationship, right? Next, few alternative ER notations that we may have are depicted over here. So even we may write many to many relationship symbol like star star on both the sides of the relationship, or we may even write many to many as n to n. Okay, then one to one, many to one, or n to one, denoting actually n towards many side and one towards one side. Similarly, we may have one to many as well. Okay, so these are few alternative ER notations. Towards right hand side, we have depicted the alternative ER notations for mentioning the cardinalities of the relationship. So in few of the books or the literatures, these kinds of symbols are also being used. So this is just for your information. Okay, now we have already gone through few ER design decisions, and let us have a list of those decisions so that we can use those decisions while drawing the ER diagram for our university database. So the first design decision that we have listed here is the use of an attribute or entity set to represent an object. So we need to take a decision whether a particular information can be better depicted as an attribute of the entity or the entity set as a whole. Also, we need to take the decision sometimes while dealing with the real world problems that whether certain information or the object or the thing is best represented by an entity set or it is best represented as the relationship set. Further, the use of ternary relationship or whether to convert the n-ary relationship into the binary relationships, that is also one of the important decisions, and that is based upon the semantics also and the efficiency of the design. Next, we are having the use of strong and weak entity sets. So sometimes we may need to use the weak entity sets as well. And if there is a situation that some information depends upon another information or some entity depends upon another entity, then we may make use of the concept of strong entity set and the weak entity set. Further, the use of specialization and generalization as appropriate. We need to make the decision whether to go with specialization, generalization to depict the modularity in the design. Further, the use of aggregation. So whether the design is more appropriate if we, or the design would be more clear if we go with the aggregate entity set as a single unit. That also can be decided depending on the problem statement at hand, right? So these are few of the design decisions those we need to have. Now, let us discuss the design of a database for a university enterprise. So we have got this example from our textbook Database System Concepts by the authors Abraham Silberschatz, Korth and Sudarshan, and the book is published by McGraw Hills Publication. So from this book we have got this university enterprise problem statement, and we are going to discuss the database design for university enterprise. So in this video, in fact, we are going to discuss the ER model for this university enterprise. So let us go through the problem statement first. So the university is organized into departments. Each department is identified by a unique name and is located in a particular building and has a budget. Each department has a list of courses it offers. Each course has associated with it a course ID, title, department name and credits, and may also have associated prerequisites. Instructors are identified by unique ID. Each instructor has name, associated department and salary. Students are identified by their unique ID. Each student has a name, an associated major department and total credits. Total credit hours the student earned so far, that is being stored as total credit. Instructors also work as advisors to the students. Next, the university maintains a list of classrooms specifying the name of the building, room number and room capacity. The university maintains a list of all classes or sections taught. Each section is identified by a course ID, section ID, year and semester, and has associated with it a semester, year, building, room number and time slot ID. The time slot is the time slot when the class meets. Okay. Next, the department has a list of teaching assignments specifying for each instructor the sections the instructor is teaching. The university has a list of all student course registrations specifying for each student the courses and the associated sections that the student has taken or registered for. Okay, so this is the information that has been provided. So this is our problem statement. Okay, now we need to carefully read this problem statement, right? So while reading in the problem statement, we may go on collecting the information like what would be the probable entity set and what would be the probable relationship. So once again, if we look at this problem statement, this first statement says that the university is organized into departments and each department is identified by a unique name. It is located in a particular building and has a budget. So obviously we may say that this department would be the entity set, right? And whatever is the description provided for the department, that description will form the attributes. So attribute would be department name would be the attribute. Let us depict it in some different way. So attributes are being depicted now using some other color, say green. So department name would be the attribute, building would be the attribute, and budget would be the attribute for this entity set department. The next statement is each department has a list of courses it offers. So we may have this course as one of the entity sets, and every course is having some attributes. So each course has associated with it a course ID, title, department name and credits. So these will form the attributes of that entity set course. Okay, and also it is mentioned and may also have associated prerequisites. So we need to understand here that we are having something like prerequisites for the course, and later on we'll see how to denote this prerequisites. Okay, now further, if we look at the next statement, it is mentioned that instructors are identified by their unique ID. Each instructor has name, associated department and salary. So here instructor would be one more entity set, and the attributes are being provided here, unique ID, then name, and it is mentioned that it is associated with department. Okay, and instructor is having salary. So salary would be the attribute for the instructor. But as it is mentioned here that instructors are associated with the department, and department we have already identified as the entity set. So this association between department and the instructor can be depicted by making use of a relationship. So this association between the instructor and the department can be depicted by making use of a relationship over here. Okay, fine. Next, it is mentioned in the problem statement that students are identified by their unique ID. So we may identify that here student is one of the entity sets. So students are identified by their unique ID. Each student has name and associated major department and total credits. Okay, now if we carefully look at this, no doubt the attributes are being mentioned for the student. So unique ID is the attribute, student name is the attribute, okay, total credit is the attribute for the student, okay, but it has also been mentioned that students are associated with major department. So once again we need to think in the similar way. So student and department we have already depicted it as the entity set. So student and department are associated. So this association between student and department, that also needs to be shown as the relationship. Okay, further, instructors also work as advisors to the students. So now here instructor we have identified as the entity set, student we have identified as the entity set, and now it is mentioned as instructors work as advisors to the students. So work as advisor. So here we may have one relationship between instructor and student to depict how they are associated. Okay, so actions usually are being depicted by making use of the relationships. Okay, so this is the action. Instructors are working as advisors to the students. So this can be depicted as the relationship set. Okay, so let's proceed with the next statement. The university maintains a list of classrooms. The list of classrooms. So university maintains a list of classrooms. So obviously whenever it has been written list of classrooms, that means we need to store some data related to classrooms. So we may identify that classrooms would be one of the entity sets, specifying the name of building, room number and room capacity. So once again here the attributes also are being mentioned, name of the building, room number and room capacity. These would be the attributes for classroom entity set. The next statement is the university maintains a list of classes or sections. Okay, so here we may think of having these classes or sections as another entity set. Okay, and each section is identified. So this is really very important statement. Each section is identified by a course ID. But if we look at this, course ID is the attribute for our entity set course. So indirectly it gives us the intuition that the sections belong to the courses and the sections depend upon the courses, and each section is identified with a respective course ID along with the section ID. So section ID being the attribute of this section entity set, year attribute of the section entity set, semester attribute of the section entity set. Okay, but these sections are identified by course ID. So what we can imagine here is this section would be the weak entity set. This section would be the weak entity set that depends upon the course. So we may think of this section as the weak entity set. Okay. Further, it has been mentioned that each section has associated with it a semester, year, building, room number and time slot ID. I'll repeat. The section has associated with a semester, year, building, room number and time slot ID. So the section is associated with it all these different components, and it has been mentioned that a time slot is the time when the class meets. Okay, now the time slot can be entity set with the attributes like time slot ID, right? And also this may have the attributes like when to meet, so a day, the start time and the end time, and so on. Okay, so we may have this one more entity set that is associated with the sections. So we may think of this association once again between the section and the time slot entity sets as one of the relationships. So we may identify that here could be one relationship between sections and time slot. Okay, now next, the department has a list of teaching assignments specifying for each instructor the sections the instructor is teaching. I'll repeat, the department has list of teaching assignments specifying for each instructor the sections the instructor is teaching. So the instructor is teaching the sections. So sections are associated with the course that we have identified here. But now the instructors are being provided with the assignments to teach the sections of the course. So we may say that here between instructor and sections we may have one relationship, that instructor teaches a particular section. So here we may identify a relationship. Instructor is teaching the sections, right? So instructor is teaching the sections. Section is identified as one of the entity sets. Instructor is identified as one of the entity sets. So teaching would be the action that is being performed. Okay, so we may consider this as one of the relationship sets between instructor and section. Okay, now let us see the next statement. The university has list of all student course registrations specifying for each student the courses and the associated sections that the student has taken or registered for. So what has been mentioned over here? The university has list of all student course registrations specifying for each student the courses and the associated sections. The courses and the associated sections that the student has taken. So it is possible for the student to register for individual sections from the courses. So this particular statement is giving us the hint that the students are registering for the sections, and that is why in between student and section we may have one relationship. In between student and section we may come up with one relationship. Okay, so let's go back once again. So what we have done is we have identified tentatively where are the possible entity sets. So department would be the entity set. Okay, then the course would be the entity set, right? Then instructor would be the entity set, student would be the entity set. Also here we have identified the attributes and few relationships. So instructor and department are associated, so we may have a relationship. The student and department is associated, so we should have a relationship between student and department. Instructors and students are also associated, so we should have a relationship between them. Further, as we mentioned here, it is provided, the information is provided like department is offering the courses, okay, and courses may also have associated prerequisites. So for one course, another course might be the prerequisite. So here we may think of this prerequisite, right, as the relationship. So this prerequisite would be the relationship between which entity sets? Course and course. One course is prerequisite for other course. So this would be a relationship between course and course. So we may make use of, actually we may make use of the role here to depict this information in ER diagram. Okay. Now further, what we have identified? We have identified that classroom can be the entity set with the given attributes. Further, we have identified that sections can be the entity set, but if we look at the semantics of the statement, then it is mentioned that courses are having the sections. So section depends upon the course, okay, and that is why we may think of building this section as the weak entity set. The attributes are being provided. Also we may think of this time slot is one more entity set. Further, it is mentioned that sections are being taught in with a particular time slot, right? So every class is having associated with the time slot. Every section is being delivered at particular time slot. So associated with this time slot and this section, we may think of one relationship. Okay. Now further, it is mentioned that department has a list of teaching assignments specifying for each instructor the sections the instructor is teaching. So instructor is associated with the task of teaching the sections. So we may identify here the relationship between instructor and section. Okay. Now the next statement says that the university has a list of all student course registrations specifying for each student the courses and the associated sections that the student has registered for. So student is registering the sections. So in between student and section, we should have a relationship because students are registering for sections. Okay. So it is not mandatory to register for the entire course, but it is possible that students are registering for the sections. Okay. Fine. So with all these problem statements and the initial intuition, what could be the entity set, what could be the attribute, what could be the relationship, now let us list out in a systematic way whatever are the entity sets, those we have identified, and whatever are the relationship sets, those we have identified. So here we have identified entity sets as department, course, instructor, student, classroom, section and time slot, right? And the attributes are also being mentioned. Okay, now similarly we may identify the relationship sets, and these relationship sets are the relationship between instructor and department. So we are depicting instructor department as the relationship, then student department. This relationship denotes the association between student and department. Then teachers is the relationship relating instructors with sections. Text is the relationship that is depicting the registration of the students for a particular section. Then we are having the association between course and department. So department is offering the courses, so we should have this relationship. Then section course, so which section belong to which course, that also need to be depicted, so this relationship. Then section class, so sections need to be associated with the classrooms, okay, where actually the classes are being conducted. So we are having section class as one of the relationships. Then section time slot, that is one more relationship that we are having. Then advisor and the prerequisites. So those many relationships, those we have identified. Okay. So now after identifying the entity sets and the relationship sets, we are going to draw the ER model, right? So here is the ER model. I am going to explain this ER model to you, how I have drawn this ER model. Okay. Now the first statement that is provided here is the university is organized into departments. Each department is identified by a unique name and is located in a particular building and has a budget. So here we have identified that department is the entity set. So we have drawn here this entity set department with three attributes: department name, building and budget. It is mentioned that department name is unique, and that is why this department name is underlined, depicting that this is the primary key for the entity set department. Okay. Now in the next statement it is mentioned that each department has a list of courses it offers. So department is offering courses. Each course has associated with it a course ID, title, department name and credits, and may also have associated prerequisites. So lots of information is being provided in this statement. So the first information that we can infer is course is the entity set. So we have made here course as the entity set with the unique identity, that is course ID. So course ID is the unique identifier of the course, so it is made as primary key with two more attributes, credit and title. It is mentioned that department has a list of courses. So courses are offered by department. So which course is offered by which department, how to get that information? So we are having here this relationship between course and department, and that is course department. Okay. Now look at the cardinality of this relationship. It is from course to department, it is many to one. Here it is many to one from course to department, and course is participating totally in this relationship. So this is total participation. So why we have shown this many to one and total participation? So here what we can observe is every course must be associated with the department. As department is offering the course, whichever course we are having, that course must be offered by at least one department. Okay, and that is why this course entity set must participate in this relationship, and that is why this is total participation. Further, about the mapping cardinality of this relationship course department, it is many to one from course to department. So why it is many to one? See, one department may offer more than one courses, so many courses. One department may offer many courses, but one course is offered by at the most one department. So it is not possible that one course is offered jointly by more than one department. It is not possible, and that is why one course is associated or offered by only one department, but one department may have more than one courses offered. So from department to course it is one to many, from course to department it is many to one relationship set. Okay, so this is the cardinality. So we have done with this, we have done with this, and also we have done with this course. Okay. Now further it is mentioned that the course may also have associated prerequisite. So as we have mentioned, the course is having prerequisite, right? So one course that is being offered may have another course as the prerequisite. So this course entity set is participating twice in this relationship set prerequisite. So course is participating as the course ID, and also the course is participating as prerequisite ID. So with this relationship, it is possible for me to depict or to store the information that for which course, which courses are the prerequisites. Which courses are the prerequisites. So this is depicted here as the role. So we are having the labels associated with those roles. So this course is participating here as course ID, so this is labeled as course ID, and this course is participating in this relationship once again as the prerequisite ID. So we have labeled it as prerequisite ID. So this is how we are depicting it as a role. Okay, so one entity set course is participating more than once in this relationship set prerequisite. Okay, fine. So we have done with this. Now, what is next statement? Instructors are identified by their unique ID. Each instructor has name, associated department, department name, and salary. So we have identified already that instructor should be the entity set. So we have depicted here this instructor as the entity set with unique ID. So ID should be the primary key for this instructor entity set. The instructor is having name and salary, and it is mentioned that instructor is associated with the department. So here already we have identified that there should be the relationship between instructor and department. So we are having here depicted this relationship instructor department between the department and instructor. Now once again look at the cardinality for this relationship set instructor department. So from instructor to department it is many to one. What does this mean, many to one? This means that one department is having many instructors, but one instructor is working as the instructor in at the most one department. So one instructor belongs to at most one department. It is not possible that one instructor is working in two departments simultaneously. Okay, so from instructor to department it is many to one. one instructor, one department. But one department can have many number of instructors, right? Also, instructor must be associated with the department, must be. So instructor should participate in this relationship. So here it is depicted as total participation. Okay, so instructor is the entity set, right? And in between instructor and department we are having this instructor department, that is the relationship set. Okay, and we have denoted now the cardinality and the participation of the entity sets. Okay, why this is partial participation here towards department? Because it may happen that the new department is being established and there is no instructor appointed yet, right? So it may happen that there is a department which is not participating presently in this relationship set. Okay, so here it is mentioned as partial participation. Okay, fine. So let's proceed now with the next statement. Students are identified by their unique ID. Each student has a name, an associated major department and total credit. Okay, so we have identified that student should be the entity set. So here we are depicting this student as the entity set with attributes ID, name and total credits, wherein student is having unique ID, so it is depicted as the primary key of the student entity set. It is mentioned that student is associated with the major department, so there should be the relationship between department and student. So once again we have shown here this relationship set student department between student and the department. So look at the cardinality. Once again, from department to student it is 1 to n and student is participating totally. So every student that we are having must be associated with at the most one department. Okay, so one student should have associated with one department. So we are having this cardinality of the student department. From department to student it is 1 to many. One department is having many number of students, so towards student it is many. But one student is associated with only one department, so towards department it is 1. Further, every student must belong to some department. So student must participate in this relationship, and that is why it is shown here as total participation. Okay. Now let us see the next statement. Instructors also work as advisors to the student. So between instructor and student we are having this relationship set advisor. Okay, the cardinality is 1 to n. So one instructor may be associated with more than one students, but one student is having at the most one instructor. It is not total participation because it may happen that few of the students are not being associated with any of the advisor. So this relationship set advisor is 1 to n from instructor to student. The reason is one instructor may have more than one students associated, but one student is having at the most one instructor. It is not mandatory that either of these entity sets should participate in this relationship, because it may happen that few of the instructors may not be associated with any of the student as advisor, and it also been possible that few of the students are not being assigned any of the advisors, right? So this, in both way, it is partial participation. Okay, now let us proceed with the next. So now the next statement that is provided is the university maintains a list of classrooms specifying the name of the building, room number and room capacity. So we have already identified that classroom should be one of the entity sets. So here we have depicted classroom as the entity set with 3 attributes: room number, capacity and building. Now, as this is a strong entity set, we should have a primary key for this classroom. Now, what would be the primary key? Whether room number can be treated as the primary key? Yes, but room number alone cannot be the primary key. Why? Because room number may not be unique, because every building may have the same room number. So every building will have room number 1, room number 2 and so on. So room number alone cannot be treated as the primary key. But if we consider this combination or set of attributes, room number, building, then it can be treated as my primary key. So room number along with the building can be treated as my composite primary key. So what is composite primary key? It is having the set of attributes. So classroom is having the primary key, which is combination of 2 attributes, room number and building. Okay, so this is about the classroom. Now what next is been mentioned? The university maintains a list of all classes or sections taught. So we have identified that we should have sections as one of the entity sets, but each section is identified by a course ID, section ID, year and semester, and has associated with it a semester, year, building, room number and time slot ID. So see here, lots of information is being provided. Section can be treated as the separate entity set, but as we have mentioned, section is identified by a course ID, section ID, year and semester. So section ID is the primary key of the course. So obviously section depends upon another entity set, that is course. So it is better that we make this section as the weak entity set, that is existence dependent upon the other strong entity set, and that is course. So section weak entity set depends upon course, which is a strong entity set. Okay, now section is identified by course ID, section ID, year and semester. Whenever we depict any entity set as the weak entity set, as we have seen while discussing it, this is associated, or this needs a strong entity set. So to identify the weak entity set, we should make use of primary key of the strong entity set. So by default, course ID would be considered to identify the section of that course. Okay, so no need to once again store course ID with this weak entity set section, but the section is having its own attributes like section ID, semester and year. So which section is being taught in which semester and which year, that we are supposed to store. Okay, and as we have discussed earlier, all these 3 attributes or combination of these 3 attributes or set of these 3 attributes will form the discriminator or the partial key for this weak entity set, that is section. Now as we know, in between weak entity set and the strong entity set, we should have the identifying relationship set. So here section course is the identifying relationship set depicted using double diamond, and this weak entity set is depicted using double rectangle. So section depends on course, and these two are related with this identifying relationship set section course. Always the weak entity set participates totally in identifying relationship set, and that is the property of the weak entity set. So weak entity set must totally participate in the identifying relationship set. So here we are having this total participation. One course is having more than one sections, so obviously towards section it should be many, and one section belong to only one course, and that is why towards course it is 1. Okay, so this identifying relationship section course is one to many from course to section, or many to one from section to course, and section participates totally in section course identifying relationship set. So we have depicted this section as the weak entity set, associated with it the identifying relationship set, that is section course. Now it has also been mentioned that the section has associated with it semester, year, building, room number and a time slot ID. So how to represent this information? So time slot can be made as one entity set. So time slot with this time slot ID is the unique identifier of the time slot. So we may have this time slot ID as the primary key for the time slot. So we are having the primary key of the time slot, so we are saying like time slot 1, and also we need to mention the day when that section is being taught, in which time slot, which day, date, start time, end time and all. So here for this entity set time slot, I am having time slot ID, which is my primary key. Say for example, I am having 4 time slots per day, say A, B, C, D, and every time slot is having some time slot, start time and end time. So my time slot ID A will be on every day, Monday, Tuesday, Wednesday, Saturday, Friday, Thursday, Friday, Saturday. Okay, B would be on Monday, Tuesday, maybe likewise. So every time slot is available on several days, multiple days, and that is why what we have done is we have created this day as the multi-valued attribute. So this day multi-valued attribute means for a particular time slot, say A, we may have multiple entries stored. So on which day and what is the start time and end time for this slot number A. What is time slot B, which is the day, what is the start time, end time. So B would be on every day, so Monday, Tuesday and so on. So multiple days may have this slot, and that is why this day is shown here as multi-valued. Okay, so I hope you must have understood this, why such kind of a design. Now time slot is associated with the section. So every section is allotted some time slot. So maybe section 1 will be conducted in say time slot A on a particular day. So that relationship can be depicted here between this section and time slot. Okay, so to deal with one section we are having here associated one time slot. But in one time slot A, on different days, we may conduct various sections, right? So from time slot to section, it is one to many, and every section must be allocated with the time slot, so it is total participation of section in section time slot relationship. Okay, so section is participating totally in section time slot relationship, and it is many to one from section to time slot. Okay, now see here, this weak entity set is not only participating in the corresponding identifying relationship set, but it is possible that weak entity set also participates in some other relationships also. So this weak entity set may participate in this relationship section time slot. Further, every section is allotted now the time slot, but every section should be taught in at some place, so classroom need to be allocated with every section. So section is allocated or assigned with the classroom. So there is a relationship between section and classroom, and that is denoted here as section class. So every section must be allocated a classroom, so it is total participation of section in this relationship set section class. Okay, and this cardinality of this relationship set section class is many to one from section to class. So one classroom may have more than one sections allocated, but one section is assigned with only one classroom. That is what this cardinality indicates. Okay, so with this statement, lots of things are being linked, and this is how we can model the ER diagram accordingly. Okay, now further let us look at the next statement. The department has a list of teaching assignments specifying for each instructor the sections the instructor is teaching. So in fact, this is a simple statement. The department is giving the assignments to the teachers or the instructors to teach the sections. So we should have the relationship between instructor and section. Sections are being taught by the instructor. So in between section and instructor, we are having this relationship set teachers. So every section must be taught by some instructor. So section is participating totally in this relationship set teachers. Okay, so one instructor may teach more than one sections. One section can be taught by more than one instructors. So it is many to many. It is many to many. Okay, so this is many to many, and towards section it is total participation, because every section should be taught by some instructor. So once again, see here that this weak entity set is also participating in this relationship set teachers other than its own identifying relationship set. So it is possible. Okay, fine. Now the next statement that is provided is the university has a list of all student course registrations specifying for each student the courses and the associated sections that the student has taken. So as I mentioned earlier also, the students are associated or the students are registered for individual sections rather than the entire course. Okay, so according to this problem statement, so we are having the relationship between student and section, and this is text. Okay, so student is registering or student is taking the section, right? So one student may register for more than one sections, and one section can be registered by more than one students. So this particular relationship is many to many. Okay, now we have shown here one descriptive attribute, that is grade. So what is this grade? Every student is securing some grade for that section. So grade should be the attribute, descriptive attribute for this relationship set text, and that has been depicted over here, right? So I think we have touched all the entity sets and the relationships, the cardinalities, and we have reasoned why the things are like this, right? So I hope you must have understood how we have drawn this ER model, right? So please try to understand. If you have any kind of doubt, then please report your doubts or queries, okay, so that you can understand the concepts better. So this is how we have drawn the ER model for our university enterprise. So given the problem statement, and we have tried to draw the ER diagram by making use of various ER model constructs. Okay, now there is some alternative notation also to draw the ER model that we have seen. So I am going to depict here the alternative way of drawing the same ER model. Only difference is how these entity sets are depicted with its attributes. That is only the difference. Rest of the things are almost same. The way the entity set and the attributes, the notation for entity set and the attribute is different. Rest of the things are exactly the same. Okay, so you may go through this kind of ER model also. We have opted for this ER model, and this ER model is drawn by making use of Dia software. Okay, so I hope you must have understood how we have come up with this model, what is the thought process, how to apply the constraints, and so on. Okay, we have seen the design considerations. So these design considerations are also been applied here. Okay, so with this we are going to conclude the discussion related to this real world problem statement of university database, and this is the design for the university enterprise ER model. So this is the basic. So this is the first model that we have come up with, conceptual model, and based on this conceptual model we are going to come up with the relational model to be implemented practically. Okay, fine. Thank you.